Hey, it's Wayne again, aka Roby. I wanted to give you a real-world demonstration of the performance of the u-blox ZED-F9P high precision, multi-frequency, multi-constellation GNSS receiver. So, if you're new to high precision GPS, which is effectively RTK GPS GNSS, then eh, you might not be familiar with what you can get out of one of these systems. And so here's what I did. You see on the in the lower right hand corner that I went to the driveway. I took duct tape and I spelled the word u-blox, the name of the Swiss company that makes these receivers, in the driveway. And I'm about to trace those letters. And I want you to watch as I trace the letters with the antenna that right now is in the lower left-hand corner of the red U. I want you to notice on the screen how it tracks what I'm doing and how closely it tracks in the Google Map image of the driveway what I'm doing. So let me set up a little more. We're using an antenna like this. This is a u-blox antenna that ships with the C099 F9P ZF9P development kit, and so it's just a really inexpensive. I think it's a $60 item. These antennas used to cost $1,000 or thousands of dollars a decade ago. Just a few years ago, it would have been $1,000 item. In general, with a GPS antenna, to get high performance, you want to use a ground plane to mitigate what's called multipath issues. But we're not going to use the ground plane with this antenna. We're going to kind of challenge the receiver a little bit to see how well it can do in a little bit of a tougher situation. I'll put some pictures up of from the perspective of the letters in the driveway of what it looks like, but all sides of that driveway are in some way encumbered by obstacles. Behind the u-blox name, that there's a big wall of trees that are it's a pretty dense wall of trees. To the west side, you see the back part of a shop. That's a 60-foot long metal shop that blocks a good bit of the view. To the north, just 5 meters to the north, is the house. Is where I'm sitting right now. And off to the east, there's a few trees. There's a road that runs parallel. You can see in the map, but there's actually a power line that runs parallel. So and we're going to use the antenna right at the ground level. So there are all kinds of obstacles that are keeping this antenna from being able to really see a lot of the satellites that would normally be available to it. But I wanted to kind of do an example just to back up why this receiver is such a big deal and to start to set the stage for why it's going to change. It's probably going to change the industry and even history eventually. So let's go ahead and do the demonstration. I'm going to zoom in on the map a little bit so you can get an idea of detail. And if you're using uCenter, there was a bug in uCenter after 1806 where you actually can't zoom in past 100%. So I use an older version of uCenter to kind of show this. All right, let's get rolling. Okay, so that's pretty amazing performance. Let's zoom in a little more. Again, this tape is a little under 2 inches. It's 5 centimeters. The antenna is a couple of inches. So the center point to center point that you're seeing, and then the lines is about 4 inches. give or take 10 centimeters from the center point of an antenna to the center point. Maybe that makes sense. Notice how small of an area, how much detail it shows. So you've got your outputting position at 10 hertz. The receiver is capable of 20 hertz. I bumped it to 10 for this demonstration. And really, a lot of the error you see is just where I had to like cross over in the U, where I had to cross over to get to the inside. And probably when you were following me, I even bumped the antenna around a little bit. It's highly precise. It's very robust. This is a tough environment. We're not even using a ground plane. We're using a cheap antenna. I'm excited to hear what you're using the ZF9P for, and I'm excited to see what industries it's going to open up very soon.